There's some rocks. There's some rocks. You can barely see them. There's some rocks moving. 3/4 minus. About 5 feet per second. What we figured from testing. Yeah, there you go. That's what we're looking for. This is the highest part. Alright, suction dredge operation. We put cam locks. Got a cap at the very bottom there. And then we just get to submerge the pipe. Don't need a pump. Let's go ahead and try it. Okay, go ahead and take the cap off. This is noticing the waterfall here.
Yeah, there we go.
And then we had to dam it up because it sucks it. Just watch. It'll suck dry. It'll suck dry the waterfall, and then we're losing, and then it goes down about a couple inches. We'll go ahead and let's see what happens here.
Yeah, it's not super good suction, but
not yet. Is cap open?
yeah.
It might take a few seconds here.
Yeah, we have some movement. Yeah.
Is it increasing? Looks like it's increasing.
It's feels about the same as it was.
Alright.
Let's see when we get the vortex.
Well, it's not going over the waterfall now.
Yep.
So we're getting good flow. I'm gonna go check.
Oh yeah, we got
really good flow again.
Good flow again. Yep.
Okay, awesome. And we end up chucking the 3/4 plus over there. I'm gonna come down here. This is only 2-inch. You can see some of the rocks. We're cranking? Yeah, we're cranking. Alright, so you can see some of the rocks flowing on this. We only have 3.1 feet ahead. I actually surveyed it with Nikon total station. And then, here we go. He's making the water dirty. It's going to come through. There's some rocks. There's some rocks. You can barely see them. There's some rocks moving. 3/4 minus. About 5 feet per second. What we figured from testing. Yeah, there you go. That's what we're looking for. This is the highest part. We got the sloped pipe here. Cam locks. And now he's cranking down over there. There. 3.1 feet with 30 foot of pipe. The sluice box, we're using that for really a nugget trap, and then it circulates around and the fines get caught. And we just shovel it into the tubs. So we got 3/4 minus that screed over there. That's for another purpose. In a previous test, we had less head, longer hose, and it was still blasting. We really needed 2 sluice boxes side by side to handle the flow. And then that little pause you saw of water was when rocks got on the nozzle. You had to clear the nozzles off the rocks. And that's what happens. It slows down, speeds up. Slows down, speeds up. I gotta clean the rocks off. The rocks on the nozzle? Yeah, get the rocks off the nozzle.
Yeah, I did, but I could feel the rocks moving right behind the spring.
Yeah.
But it's not touching honey at all.
So the previous video was the second time we went out. The first time we went out, we actually had lower head and longer pipes. And we still pulled this right out of the sluice box. These made it through the nozzle, through the pipes, down to the sluice box, and I picked them out of the sluice box. And I was pleasantly surprised, particularly this guy, very aerodynamic, that he didn't get stuck in the pipe and then make his buddies stick with him and plug up the piping. So 3/4 inch minus all the way to the sluice box.
Come out of the water either.
Oh. So here we go. The nozzle got some of the holes filled out. The waterfall is gonna, as that thing pulls water out, the waterfall stops. We had to dam that up.
It's weird, this It didn't come out of the water.
Huh. There could be some, might be some stuff stuck in there. Oh, no, it's
Still moving?
still moving. I'd love to have a 6-inch with 10 times more material. 9 times, maybe 10.
Good suction, but very weak.
Still need more head to be more consistently flowing. We need more water so we can be more consistently flowing. But that nozzle right there, I tried it, didn't do so well. A lot of people like, oh yeah, buy a fire hose nozzle. Oh yeah, no, just don't. So what we got here is the same line that we used for a gravity suction dredge to the sluice box, and we hooked it up to an old screed. That's me cleaning out the Keen sluice box. No nuggets. We never get nuggets up there. Anyway, so I added the well, this is the days before cheap high bankers. So we had probably a foot to a foot and a half ahead, same pipe, very little head loss, except those holes, the orifices there that would be used to do the wash plant. That's me doing a clean out, miracle map. That's me, Chief Operation Manager of a 3-man crew, plus being Principal Engineer, plus Constant Maintenance Guy. I took that screed and added hopper steel and put it over a miracle mat, and it's done very, very well, actually. We did a test. 10 buckets regular sluice, 6 buckets through the miracle mat, and we got 6% more gold. Of course, now there's cheap high bankers. We got rained out, so we had to call it quits. Drenched, absolutely drenched. Summer storm, 1/2 inch to 1 inch. I wonder if the environment did more damage to the environment than 3 miners moving about 6 to 8 buckets. So I want to continue the discussion why a tapered nozzle failed. Massive head loss. But what happened was, on one of my claims, there was creek flowing. Like, I can't believe it's still flowing, so I was desperate to get out there and do some gravity suction dredging. So I threw this design together on AutoCAD and basically cut where the steel is, just mark it and cut it, pound it, weld it. A buddy named Bill did this for me. It was very awesome of him, and it's really good for sucking out crevices and cracks. But as far as using it for bigger rocks, it ain't going to work very well. It doesn't work very well. We'll get to that. We tested it in the field and we proved it. But my buddy made this little flapper here, because when you're getting 20 feet per second, that's what in my field condition, 20 feet per second going through here, you're going to get a hard time pulling out a rock. So, I put a ring here. That would be helpful, of course. But the main line flow, 2 inches, was going to be too slow to move the rocks, and it was going to get plugged. And so when a rock is stuck here, you can pull that little flapper there. And so we field tested it with results for the other nozzle that I call the Chris nozzle. The Chris nozzle worked very well, and my buddies want to go out mining again. So here is the field results and my estimated fluid mechanics results. Okay, but what happened was, while Bill's building this one, I did the fluid mechanics. I'm like, we are not going to get rocks up, and we're going to get plugged. We are going to get plugged. So the field test, we found the nozzle had a velocity greater than 20 feet per second. Main velocity in the 30 feet of 2-inch pipe, which I say a continuous 2-inch between a hose and a pipe. We had 2.1 feet per second, and that's for 30 feet of hose and pipe, 3.1 feet of driving head, which I surveyed, was around a 10% slope. The side of the material passing through is 3/4 minus. Now, why 3/4 minus? Because I calculated that anything bigger than that's going to get stuck. And we did have a little problem with the Chris nozzle, the one you saw in the previous video, in the field. But we just tapped on the highest point and the rocks disappeared. So, but pretty much, as long as we kept our siphon, we did very well. So, The bill nozzle tapered. The field velocity of the nozzle right here was over 20 feet per second. The main line, all 2-inch, was 2.1. Okay, my estimate by fluid mechanics was around 2. That's why I redesigned a custom nozzle. Well, we'll get to that. So with the tapered nozzle, when I opened the flap, we got a higher mainline velocity. Instead of 2.1 when the flap was closed, we got 2.7 when the flap was open. But still, the head loss from the nozzle was just too excessive. And it would be kind of crazy to, well, spend all day cleaning out your pipes, redoing your siphon, get your siphon going again, and then fill up with pipes. So that's why I did this design. I'm trying to help miners realize certain things here for gravity suction dredging. Used a couple books here as references. There's one more book I used for fluid mechanics. Being an engineer, I calculate pretty relatively easy. But yeah, the Chris nozzle, the nozzle velocity of the entry was about 8.8 feet per second. I knew I had to bring that down to keep the main line velocity up 6 feet per second. That's field numbers. This is my estimate with fluid mechanics for the main line, which is 5.4 to 6.5. And the head loss from the nozzle was 1 foot, and it kept 3/4 plus material out. Again, we did pretty well. So the conclusion I had, the tapered nozzle will cause material to pile up in the hose and the pipes and failure. And of course, helping other miners, you can, well, look for another nozzle. Maybe even something like this, but you put a ring in front of it. But you gotta watch the size of the material, because I don't think it's going to pull 1.5 inches up. I don't even think it's going to pull the 1-inch material up. You're going to get your pipe clogged. So anyway, but yeah, the Chris nozzle, it did really well. And my mining buddies that went out with me, they want to go out again with this system. Again, we only had 30 feet of hose, 3.1 feet of driving head, because I surveyed that with top Nikon survey gear, about 10% slope. So you can read that about how we measured the field velocity. We got to improve that method, but I was pretty pleased that the fluid mechanics range came within the actual field velocity, and that's what fluid mechanics can do. The reason why I have a range here is because the different C values for the entrance loss of the Chris nozzle. So we had, it worked. We moved probably 6 to 8 buckets in many hours. And how much gold did we get? Yeah, we found gold. I'm not going to tell you how much gold we got, but this is about the fluid mechanics. Now, you can go ahead and contact me if you want. I can evaluate your system, how much head loss you're going to have in the main line and how much flow loss you're going to get. But anyway, I can help with that too, nozzle design. And basically analysis, how much velocity are you going to get to keep your pipes clean, so you don't spend all day stopping and then cleaning out the pipes, restart your siphon. Anyway, so that's, send me a text first. If you're going to call me, send me a text. Otherwise, I'll think you're a telemarketer, probably won't pick up. So other clients, engineering clients, my voicemail is just full. So, but yeah, trying to help some miners here and make your day out mining as enjoyable as mine has been. So there you have it. A tapered suction nozzle for gravity is going to fail unless you got an enormous amount of head. And the slope there is about 10%. We didn't have much good results with that, but it will work well for sucking cracks. So that's the results there. I don't recommend a tapered nozzle. But yeah, if you guys want to call me, hey, great. I'm going to start charging for engineering. What, I don't know. I might just sell the nozzle design, the one that works. And but I did want to just check out what the mining community thought of this. And if we do get in engineering, I am going to charge you though. That I just am be upfront about that. I can't do stuff for free, and I got other clients competing for my time. But I'm glad to talk to you, 10, 15 minutes. And if you don't utilize engineering, well, hey, that's great. Really enjoy the time out in the woods like I do.